Hello and welcome to section 2.2 in dual pre-calculus. We're going to talk about absolute value functions. So let's interpret the way this definition is written here. So the absolute value of x, there's two cases. The first case is when x is less than 0, and the second case is when x is greater than or equal to 0. So when x is less than 0, we're talking about negative x values. All right. When x is greater than or equal, we're talking to greater than or equal to 0. We're talking about positive x values. All right. So that just means that when x is negative, the absolute value of a negative number is going to equal to 5, the positive version of that number. All right. If x is a positive number, then it's still positive. All right, so we already know that. That's something we've learned before. So we know that there's two answers for most absolute value equations. Okay, so let's practice. This is something you guys might remember somewhat from Algebra 2, but let's go through some examples here so that we can refresh our memory. So for example 1, we have the absolute value of 3x minus 1 is equal to 6. All right? So what we're going to do is we're going to set up two equations. We're going to say the inside could potentially be positive, or the inside could potentially be negative. And we're going to solve those two equations for two different values of x. So we add 1. So that's 3x is equal to 7, or x is equal to 7/3. And then over here we have 3x is equal to negative 5, or x is equal to negative 5/3. All right, and you could substitute those back in there and verify that you get a true statement. If I put 7/3 back in here for x, I'm going to get 3 times 7/3, that's 7. 7 minus 1 is 6. The absolute value of 6 is 6, so that one works. If I put negative 5/3 in, I'm going to get 3 times negative 5/3 is negative 5. Negative 5 minus 1 is negative 6. The absolute value of negative 6 is 6, so that works as well. So we have two true x values that make this statement true. Two solutions. All right, if you take a look at number 2, we've got a little more stuff happening here. So you want to be careful that you use your solving techniques properly. So remember, we subtract first. So I'm going to subtract. So I've got negative absolute value of x plus 5 is equal to negative 2. All right, and then we're going to divide by negative 1 on both sides. So I'm going to get the absolute value of x plus 5 is equal to 2. Okay, once you've got the absolute value bars isolated on the left-hand side, you're ready to set up your two equations. So you want to make sure that you do that first. So I've got x plus 5 is equal to the positive 2. X plus 5 is also equal to the negative 2. So this one says x is equal to negative 3. This one says x is equal to negative 7. Now you want to verify that. If you put negative 3 back in here, you'll get 2. So the absolute value of 2 is 2. 3 minus 2 is 1. This one checks out. If you put negative 7 back in here, you'll get negative 7 plus 5 is negative 2. Absolute value of negative 2 is 2. 3 minus 2 is 1. This one also checks out. So good job. Let's take a look at number 3. So once again, you got to follow your solving rules, which means I got to add 5 over there first step. I'm going to add first. And then I'm going to divide by 3. And I have 5/3. I've isolated my bars, so that means I'm ready to set up two equations. So I'm going to say the positive equation first, so positive 5/3, and then the negative equation, negative 5/3. All right, so I suggest you clear out the denominator. So that means I'm going to multiply everything by 3, which means then I can cancel here. All right, get rid of that denominator. So I've got 6x plus 3 is equal to 5. 6x is equal to 2, or x is equal to 2, 6. So x is equal to 1/3. All right, so that's one of them. Now let's multiply everything by 3 again. So that's 6x plus 3 is equal to -5. 6x is equal to -5 minus 3, so that's -8. X is equal to -8, 6, or -4/3. All right, so we believe those are true. So if we go back up here, let's see what we've got. So if I put 1/3 in here, that's 2/3 plus 3/3, that's 5/3. Absolute value of that is 5/3. Times 3 is 5. 5 minus 5 is 0. That one checks out. If I put -4/3 in here, I've got -8/3 plus 3/3 is -5/3. Absolute value, so that's 5/3 times 3 is 5. 5 minus 5 is 0, so that one checks out as well. All right, taking a look at number 4. So you want to add or subtract first. So I'm going to subtract 4 from both sides. And I'm going to get 1 over here. Now I'm going to divide by -1. And I'm going to get a -1 on the right-hand side. Okay, so that raises an alert right there, because the question is, can you ever take an absolute value of any number, positive or negative, and have it wind up having a negative result? Okay, that's not possible. So there's going to be no solution to it. If you see that right here, a negative on the right, when everything else is isolated within the bars on the left, you're going to say no solution, or NS. Okay, there's no way you can come up with a solution to this problem. Okay, so be on the lookout for that. All right, this one has x's on both sides. All right, so the bars are isolated, so we can go ahead and set up our two equations at this point. So we're going to say x, the positive, is equal to x squared minus 6. Over here, the negative, x is equal to the negative of what you have on the right-hand side. Okay, so notice I put the negative outside and put parentheses around that whole right-hand side. So I'm negating the whole entire side. All right, these are quadratics now. So let's move everything to one side. So I've got x squared minus x. I'm moving the x, this x over here to be with these two terms over here. All right, so x squared minus x minus 6 is equal to 0. Let's do one side at a time here. Okay, so we're going to have to solve a quadratic here. So remember, we can factor if possible to solve a quadratic. So I've got a 1 here, and I've got a -6 over here. So let's just find our possibilities. So 1 times -6, I'm just going to make a little chart here. So what are the ways to multiply to get -6, to multiply to get 6? We'll talk about just 6 first, then we'll deal with what we do with the negative. So I could have 1 and 6, that multiplies to give 6. Or I could have 2 and 3, that multiplies to give 6. But the question is, I have to multiply to give -6, so I'm going to need one negative factor. Now determine which factor is negative. Right here, they have to add up to the coefficient in front of the middle term. All right, so I'm going to put my negative on the 3 here, because I can see that 2 plus -3 will add up to -1. All right, so I know that my two numbers are 2 and -3. Those are going to go in my factors, 2 and -3. Okay, so we can solve both of these by setting them equal to 0, I'm going to say x is equal to negative 2 and x minus 3 is equal to 0, x is equal to 3. Okay, so I've used the idea that if x is equal to negative 2, negative 2 plus 2 is 0. 0 times, this would be negative 5, is of course 0. If x is equal to 3, then this one is 0. 3 minus 3 is 0. 3 plus 2 is 5. 5 times 0 is 0. So if either one of these factors is 0, you're going to have a true situation. All right. Now we got to check at the end to make sure they satisfy the original equation. But let's go on to the other side now. All right. So let me do it in green. So I've got x is equal to negative x squared plus 6. All right. So I'm going to put the x over here. So I've got negative x squared minus x plus 6 is equal to 0. All right. So let's just put the 0 on the other side so it looks better. All right, so don't try to factor anything that has a leading negative. So if you divide all of the terms by negative 1, you'll have this polynomial. All right, so we're going to try to factor that again. So I've got 1 times negative 6 is negative 6 again. So these are my factors. This time I have to add to get a positive 1, and I have to multiply to get a negative 6, so I still need one negative, so it's going to be here this time. So that's 3 minus 2 is 1. 3 times negative 2 is negative 6. So my factors this time are x minus 2, x plus 3, all right, and then we know that this one would be x is equal to 2, and this one be x is equal to negative 3. So at this point, we have 4 potential solutions, here, 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 and here. All right, so let me make some room for ourselves here. So what can happen when you're solving quadratics and you started out with an absolute value equation is that you could potentially get what we call extraneous solutions. We don't go into that too much in Algebra 2, but they can exist when you're solving an equation that has that squared term in there. So we got to try them all out one at a time. So first we'll try x is equal to negative 2 and see if you get a true statement. So I just plug it in there and test it out. So that would be 2 is equal to 4 minus 6, so that's 2 is equal to negative 2. Well, that is definitely not true, so that one's not a solution. All right, so now we'll try out 3. So absolute value of 3 is equal to 3 squared minus 6, so that's 3 is equal to 9 minus 6 equals to 3. So that one is true. So this one is a solution. All right, and then let's try out positive 2. So that's absolute value of positive 2 is equal to 2 squared minus 6. 2 is equal to 4 minus 6. 2 is equal to negative 2. So this one doesn't work either. All right, so one more to check out. Negative 3, absolute value of negative 3 is equal to negative 3 squared minus 6. So that's 3 is equal to 9 minus 6. 3 is equal to 3. So that one worked. All right, so what we've got here is 2 extraneous solutions, so those are not solutions, and we have 2 real solutions that actually are solutions. So x is equal to 3 and negative 3 are the solutions to this equation. Okay, so let's see what happens with number 6. So I've got to isolate the bars first, so x minus 2 is equal to x, subtract the 1 over to the other side. All right, now I'm ready to set up my 2 equations. So I've got x minus 2 is equal to the positive version, so that means nothing changes on the right. And then I've got x minus 2, let me just go over here, x minus 2 is equal to negate everything on the right, negate the whole thing. So I put those parentheses in there. All right, so let's do them separately here. So on the left equation here, I'm going to subtract x from both sides. So I've got negative 2 is equal to negative 1. Okay, so that doesn't lead us anywhere on that side. All right, so that doesn't give us a solution. Now over here, I've got x minus 2 is equal to negative x plus 1. So let's put the x's together. So I've got 2x minus 2 is equal to 1, or 2x is equal to 3, or x is equal to 3 halves. All right, so it could be that x is equal to 3 halves, but we're going to check it out. All right, so let's do that in a different color. So I've got the absolute value of 3 halves minus, let's call that 4 halves, plus 1 is equal to 3 halves. So that's 3 halves minus 4 halves. So let's move it up a little. That's equal to the absolute value of negative 1 half plus 1. Is that equal to 3 halves? All right, so that's 1 half plus 2 halves, and that is equal to 3 halves. Okay, so that checks out. So we have a solution, and we got it from the right-hand side this time. All right, now we're going to do some graphing here. So let's first graph the parent function of the absolute value of x. So we went into great detail on that when we were back in one of the earlier sections. So we can just go ahead and, let's see, let me get my pen working here. So I'm going to draw it. This is the absolute value function. Remember, it's shaped like a V. All right, so there it is. All right, now we're going to translate a few of these. So this one over here has got a translation in the inside, so that means it affects your x's. So if it's a negative on the inside, we're going to go right 3. All right, so I'm going to move my entire graph to the right 3. All right, so right 3, and then otherwise it's going to retain the same shape. Okay, so that's number 2. All right, so let me get rid of some of this. All right, and number 3, this number on the outside here means I'm going down by 3, so that affects my y values. So the whole entire graph is going down by 3, so the point goes down by 3, and then I'll just get the same shape in here, like this. Same slope to these side lines. All right, so that's number 3. Okay, so on the last one, we're going to do some translations here of 3 points, the points 0, 0, 2, 2, and negative 2, 2. These 3 points, so you want one of the points to be the vertex so you can get the shape in there, and then one to be symmetrically opposed to the other one on each of these linear sides of the V. All right, so let's do the x's first. So for the x's, we're going to say the x coordinate of the point I'm translating is equal to 3x plus 1. So 0 is equal to 3x plus 1. So that means 3x is equal to negative 1, or x is equal to negative 1/3. All right, and then we'll change it to the x coordinate of the second point, which is 2. So that means 3x is equal to 1, or x is equal to 1/3. And then we'll change it to the x coordinate of the last one. So we have 3x is equal to negative 3, or x is equal to negative 1. Okay, so that takes care of the x coordinates. Now let's translate the y coordinates. So we've got multiply by -2 and then add 4. Okay, so we're going to take this y coordinate of 0 and we're going to multiply 0 by -2, so that's 0, and then I'm going to add 4, so that's 4. All right, that's my vertex. And then the next point, I've got a y of 2. I'm going to multiply that by -2, so that's -4, and add 4, I'll get 0. So that looks to be an x-intercept. And then the last one is got the same y coordinate there, 2 and 2, so this must be also a 0 here. So we've got both of the x-intercepts. All right, so I'm going to graph this thing. So the vertex is at -1/3, 4, about right there. And then one of the x-intercept is 1/3, 0. The other one is -1, 0. And then I'll sketch it in. So I sketched it in. So you can see from the translations that's reflected over the x-axis. It's elongated by this factor. It's moved to the left by this inside part here, and it's raised up by 4 by this outside part here. Okay? So now we'll take a look at this graph and we'll write an equation for it. So the first thing you want to do is get the vertex moved, and then we'll decide whether there was some kind of dilation or compression. All right, so that dot there, if we started out with your parent function being vertex being at 0, 0, I can see I went 1, 2, 3. So I went 3 to the right, and then I went 1, 2, so I went up 2. So I could say that my function f of x that made that graph had a right translation of 3, so it means I'd have to put a negative in there, and then had an upward translation of 2. All right, now the only thing we don't know is whether it had a dilation by some factor there in front. I'm going to put an A in there right now. All right, now what we can do is figure out what happened. If we can read a point off of here, we can figure out what that A is pretty easily. So I'm looking at a point that I can read here, and here's one here that looks pretty good. That point is 5. This one right here is 5. Looks like 6. So I have an x of 5 and a y of 6. So that is a solution to this equation. It lies on that graph. So y is the same thing as f of x. So I can say if f of x is 6, I don't know what a is yet, and x is 5, putting the rest in here, I should be able to solve for that a value if I do this stuff here. Okay, so if I subtract, let's subtract this 2, so that got 4, is equal to a times the absolute value of 2. So that's 4 is equal to a times 2. So that means a has got to be 2. All right, so that means I've got to have a 2 in that spot there where the a is, right there. Let's move that. So f of x is equal to 2 times the absolute value of x minus 3 plus 2. All right, now you can always test it out to see whether you did make any mistakes or not by just choosing another point there, one that you can read, like that one, for instance, sticking it in for y here and x here, and seeing if your left-hand side of the equation and your right-hand side of the equation are equal. That would prove that you had found the correct a value. Okay, so that covers it for this section 2.2 on absolute value graphs. If you have any questions, you just need to let me know. Best way to do it is via Remind, because we can transfer those pictures between one another fairly easily. You could take a picture of your screen, you can take a picture of your work. In any case, you let me know whatever questions you've got, and you should be ready to start on the assignment.